Hello students, how are you all? I hope you all are fine. So in last few videos, we have learned about the types of relation, how you will tell the particular that is a which type of relation. So today we are going to learn about the type of function. Okay, today we are going to learn about the type of function. So before learning the type of function, first of all, you should know what is function. So in I have told you that if you want to learn what is function, so go through the video that I have dropped for the 11th class student. In that I have discussed about the function. What is function? If which relation can be called as function. Okay. So for relation to be function, every element of first set should have unique image in the second set. Okay. So that is function. So here we are going to learn about the type of function if you want to learn. So about the function clearly to go through the back videos that I had dropped earlier for the 11th class. Okay, so let us start our type of function. So here types of function. Okay, so there are two type of function. First, see one function, many one function. Okay, so one function called as injective function. One called one function called as injective function also, and second one is many function, many one. Okay, now one function and many one function both can be into function also onto function. If that is onto function, that it will called as surjective. Okay, and one also type of their bijective. Okay, bijective means if function showing injective property also surjective property also, then that type of function is called as bijective function. Okay, so here I have written some example of a function. Okay, function that giving the example of particular types. Okay, so first of all we will try to learn about these by mapping also. Okay, so here I am making some mapping. Suppose this is set A, this is set B. Suppose that here elements are 1 2 3 4, here A B C D. So suppose in this every element have unique image. Okay, only one image. Okay, now second one I am drawing. Suppose two sets are there, AB 1 2 3 4, A B C D. Suppose one have unique image A, two have unique image C. Okay, so see this function. Now see the next one. 1 2 3 2 3 4, A B C. See here, see this. Okay, let us draw some one more. A B set 1 2 3 4. Okay, A B C. Okay, I will tell about this thing later. So first of all, see here. In this, every element has unique image. Okay, and in this, no element is left. Every element is met by the element of first set. Okay, so this type of function is called as one function. Listen, okay, this type of function is called as one function. Okay, now see this. In this also every element have unique image. One have unique image A, two have unique image A, three have unique A, four. But in this, two elements have same unique image. One also have a unique image, two also. It means in this many element have one unique image. then it is called as many one function. See here. Okay. This is called as many one function. Okay. Now in this also, see, two elements have unique image B, and every element have unique image. Okay. But in this, one element is left to be mapped. See here, in this, one element is left to be mapped. Okay. If you are seeing in mapping key, every element is have unique image, and one element is left in the second one. So you can see this is many one. This is many one, but with many one, this is into function also. This is called as into function. If any element is left in the, okay, then it is called as into function. Now in this, every element have unique image. Okay, so this showing 1 1, but in this also one element is left, then this is called, first of all, see, this is showing 1 1 function. Okay, but here it is left. Okay, then it is called into function. Okay, and in this not left, see, in this not left, in this not left, then one with 1 1, this is also onto function. This is also onto function. See here. Okay. Again, I am repeating. Try to understand. So 1 1 means every element have unique image. Okay. One element have one unique image. One element have one unique image. So see this one, and see this one. Okay. See this one and this one. Both are 1 1 function. But what is the difference between them? In this, no element is left to be mapped. Okay, that's why it is called as one to onto function. Okay, in this, one element is left to be mapped. That's why it is called into function. Now see this. Okay, in this, two element have same unique image. One also have, two also have. See in this, one also have B, two also have B. So both are many, means two elements have same unique image. Okay, not than. Okay, so that's why both are called as many one function, first of all. Okay, now in this, no element is left to be mapped, and in this, one element is left to be mapped. If you see this type of condition, then in this way, this is called onto function, because no element is left here, and this is called into function. Okay, many one, with many one, it is into function also. Now see from the chart. So function can be divided as two parts, one function, many one function. If it is one, then it is called as injective first. Listen, okay. Other name is injective. Many one is there. Now see, both can be two type. Both can be two type. One can be into also, onto also. Many one can be into also, onto also. Okay. So see here, one onto, one into, many one onto, many one into. Okay. Now see, if any function onto is there, okay, means suppose this is one onto and many one onto. Okay, this one. So both can be surjective. Both can be called as surjective also. Okay, if this is condition. Now see the one more type. One more also there, bijective function. Okay, the bijective means a function showing both property, injective also, surjective also, then that type of function will called as bijective function. Okay, so bijective means function showing both property, injective also, surjective. Which one we have said? Injective means function should be first of all, function should be injective, one function. Second thing, that thing, surjective also, means this one. means 1 1 on 2 means this one called as surjective also, this one called as surjective also. Okay, this one not. Okay, this one called as surjective also. Okay, so 1 1 also there, on 2 also there. See, this is also many one on 2 surjective. Okay, sorry, bijective, we are talking about bijective. So bijective, okay, this will called as bijective, and this both surjective. Okay, this both called as surjective. If 1 1 on 2, many one on 2, surjective. If 1 1 on 2 only, that will called as bijective function. Okay, see here. Now let us see the following example given here. See, for 1 1, I have written some examples. See, first example is fx is equal to 1 upon x. Fx is equal to 1 upon x. So if you will put x is equal to 1, then you will get 1. Means at 1 you will get 1. At 2 you will get 0.5. Means in this way you will see every element have unique image. Okay, means every element has unique image. Okay, no common element will be there, means it will not show like many one. Means every element will be, means this will show like this. Okay, so that is why 1 upon x is called as 1 1 function or injective function. Now see the fx is equal to x square, fx is equal to fx square, and here it is written condition also. Ki what? Ki n tends to n, mean here we have to take only natural numbers. So if you will put 1, then you will get 1. If you will put 2, then you will get 4. If you will put 3, then you will get 9. Means if you every element have unique image. Okay. Okay, so 1 have 1, 2 have 4, 3 have 9. In this way, means every different value have a different image. Okay, means image will not come same in this way. So you can see fx is equal to x square is also a 1 1 function. Now see this one, fx is equal to x cube. Again here x cube is same. If you will put c 1, then you will get 1. If you will put 2, then you will get 8. If you will put 3, then you will get 3 3 9 3 27. See here. So in this way, for every different value of x, you will get different value of fx. See here, you are getting na, means this is showing 1 1 function. Okay. Now let us talk about the mini one function. So see here, we have taken here fx is equal to x square, and we have to take natural number here. If we change the condition, f is such that z tends to z, means if you take integer, then you will get the integer. So obviously, if you will see, if you will put -1, then you will get, means if you will put -1, then you will get 1. If you will put 1, then you will get 1 also. If you are putting -2, then you will get 4. And if you will put 2, then you will get 4 again. See, so two elements have same image. Two elements have same image. Means this type of, see, this type of, okay, this type of coming. Okay, so see here, if you will do the mapping, then -1 you take, 1 2 1 take, -2 2 take, then here only you have to make 2, sorry, 1 and 4. Okay, so see here, okay, so 4 is the image of -2 also and 2 also. 1 is the image of -1 also and 1 also. So you can see in this many one function is showing. Okay, many one function is showing. And also what it is, what onto function, it is onto function also. Okay, because no element will be left in this. Okay, in this also no element will be left. See here, I have written. Okay, so if you change the condition, then type of function get changed. you have written fx is equal to 0, fx is equal to x square, and you have taken condition n tends to n. Here fx is equal to x square, z tend to z. So you can see, okay, what value is coming, okay, and whatever value is coming integer also. Okay, so this is the example of many one. Now see the, now what I told you, both type of function can be two type, into also, onto also. Okay, so how you will turn into, if any element get left, if any element get left, okay, then you will say that it is into function. And for onto, if no element left, see, fx is equal to x square, and you have to take r 0 to infinity, means you will not take any negative value. You have to at 0 you will get 0, at 1 you will get 1, at 2 you will get 4, है ना? So after you will see some element will get left. Here also you have to take 1, 2, 3, 4, 5, 6. Here also you have to write 1, 2, 3, 4, 5, 6. Okay. So see here, at 1 you will get 1. See, at 2 you will get 4. At 3 you will get 9. Suppose here 9 is written. So you see, here 2 element get left. Here 2, 3 element. है ना? You can see on 2. Okay. So see here. So every element have a unique image. Every element have a unique image. Means on putting the value, you are not getting any. Means every element have a unique image. See here. Okay. If you will take fx is equal to 2x plus 1. Okay. So here also 149 real number. Here also these are real number. Okay. Now if you will take 2x plus 1. So if you will put 1, you will get 3. If you will put 2, then you will get 5. Means every element have a, okay. So see here. So this is called surjective. No, with the no elements is getting left to be mapped. Okay. Okay, understood. See this example. Also written fx is equal to x plus 1, fx is equal to 1 upon x. See here, whatever written here. So this is the example of when 1 and onto also, because no element will be left to be mapped. Okay. Now see the bijective. Bijective means this will show both one, injective also and surjective also. Injective means this will be 1 1, and surjective means this will show onto. Okay, onto means, see, no element will be mapped. Okay. So see here what is written, 2x means on putting 1 you will get 2. On putting 3 you will get 6. On putting 2 you will get 4. Means every element, means here it is saying n to e. Means e is even natural number. On putting natural number you will get even number only. Okay. So see here, 1, at 1 you will get 2, at 2 you will get 4, at 3 you will get 6. So even number you are getting. And you have to tell ki this showing both one, injective means 1 1, so 1 1 showing every element have a unique image. Surjective means should be onto, means no element should be left. Okay, to mapping, for mapping. Okay, so here no element is left in. See, if you will make like this key, suppose 1 2 3 you have taken, and even number you have to take, suppose 2 you have to take, 4 you have to take, 6 you have to take. So add 1 you will get 2, add 2 you will get 4, add 3 you will get 6. See? So every element are mapping na. Okay, that's why it is called as bijective. See here. Okay, so see here. So how I will tell you to get how you will define the type of function. So there are two type of function, one function, many one function. Now one function, many one function can be two type, into and onto. If onto is there, that will called as surjective. If one is there, it is called as injective. Okay. So by mapping, I will tell you. After that, here some examples are written. See. Okay. On the basis of these example, you can tell about this. Okay. So I hope you have understood. Okay. So types of function. So in next video, I will discuss about this thing again, okay, with some more examples to make clear concept related to the types of function. Okay, so if you have liked the video, then share and subscribe it, and wait for the next video. Till now, thank you. Have a nice day.